This video is to deal with kites from Unit 8 quadrilaterals. We're going to go through and take a look at the properties of kites and then go into the problems and apply them to see just what they actually look like. This video is for some properties of kites. We're going to go and start by looking at the properties of the kites and then looking at how we can apply them in problems 10A and 10B. We'll start off by looking at the sides and angle properties of a kite. To start with, there are no sides parallel in a kite. So all the other shapes we've dealt with so far, we've had opposite sides, or at least one set of sides being parallel. There are no sets of parallel sides in a kite. Another thing that's different is usually we have opposite sides being congruent. In this case, what we have is we have two disjoint consecutive sides, so side-by-side sides, being congruent. And we can see that here. The short side is congruent to this shorter side, and they are in fact side by side. They are adjacent to each other. And we also see that this longer side is in fact congruent to this longer side, and they are not opposite of each other. They are in fact just adjacent to each other. So that property actually shows up in 10B, where we see that in this kite ABCD, we know that the adjacent sides are congruent. So we know that side AB is congruent to side AD. And we know that side BC is congruent to side CD. So we can set up the following relationship. That 2z minus 5 is congruent to 13 or equal to 13. And 8y minus 2 is equal to 22. So solving these two-step equations gives us that z is equal to 9 and y is equal to 3. The last property that's relevant in terms of sides and angles in a kite is that we have one pair of opposite cross angles that are in fact congruent. Normally we have two sets, but in this case we have one set of opposite cross angles are congruent. That doesn't show up in terms of any of the problems we're dealing with, but that is relevant occasionally. Properties of the diagonals. We see, again, just like in the rhombus, that the diagonals are perpendicular, meaning that they form 90-degree angles, and we can see that right here. The two diagonals intersect, and they form 90-degree angles all around. The main diagonal is that a longer of the two diagonals, and a cross diagonal is the shorter of the two diagonals. The main diagonal actually bisects the cross diagonal. So as we can see here, this piece is the cross diagonal, and it is in fact cut in half by our main diagonal. That property we can actually see in problem 10B, where we have our cross diagonal, this piece being x plus 4, this piece being 16. So we know that they are in fact congruent, giving us the relationship that x plus 4 is equal to 16, which once we solve this one-step equation is that x is equal to 12. Okay, the last set of properties that we see here, I'm going to kind of relate with our first one, is they usually go hand in hand. So the diagonals are perpendicular, meaning they form 90 degrees. What also happens is this main diagonal bisects a pair of opposite angles. So what we see happening is that in our kite, normally we have one set of opposite congruent angles. Here we don't have two angles that are congruent, but we have angles that are in fact split in half. So this and this are both equal. So these angles are split in half, along with the idea that this angle right here is split in half with that angle. So we have two half pieces looking there. So if we actually take a look at problem 10A, we should see that, all right, I'm looking for x, y, and z. So focusing in on this, we actually can figure out that, hey, my cross diagonal intersects my main diagonal, and we know that all of these values are 90 degrees. So therefore, x is in fact equal to 90 degrees. These are all 90 degrees, so therefore x is 90 degrees as well. Okay, well, we know that the main diagonal bisects these angles. So looking at this angle, this whole angle, we don't know what the value is, but we also know that this piece is z. For this angle, we don't know what the We weren't given it right off the bat, but I know that each of these pieces are congruent. So therefore, y is equal to 35 degrees. Now, to figure out what our value of z is, we should note that we have a 90-degree angle here at all the intersections. We have a 61-degree angle, and we have angle z, and they are all located in, you guessed it, a triangle. So via our triangle sum theorem, we get the relationship that z plus 90 plus 61 equals 180, or that z is equal to 29 degrees. We had a couple problems we had one problem like this on our exam where we had to use the property of the main diagonals bisect opposite angles and then actually go ahead and utilize, again, the triangle sum theorem to figure out a missing angle. Just like with rhombuses, this property shows up quite a lot. We could use the Pythagorean theorem as well. That's also possible. But here the triangle sum theorem worked out for us.